Welcome to Ruwa Perfect classes. I am Dr. Rachana Rana. In this video, I will discuss about types of sets. First, finite sets. Second, infinite set. Subsets, proper sets, improper sets, universal sets, null set or empty set, singular, tone set, equal sets, equivalent sets, disjoint sets, and error sets. Now first we have to know that the sets are categorized into many types which are based on elements, types of elements, and these different type of sets in basic set theories. First I will discuss about finite sets. A set is said to be finite set when it includes exactly n different elements where n is a non-negative integer. N is also known as cardinality of sets, and the cardinality of sets is denoted by this symbol and hash a, card a, or na. You can represent any one of way, and you can say number of element is finite. Cardinality of empty set theta is 0 and is denoted by like this: theta is equal to 0. And sets of even positive integer is not a finite set. Sets of even positive integer is not a finite set. Finite sets are also known as numerable, or you can say numerable sets. And second type is infinite numbers or sets. A set which is not finite, that is known as infinite sets. And infinite sets further divided into parts. First is countable infinite sets, second is uncountable infinite sets. Or you can say the number of elements are infinite, which you cannot count, you can count. If there is one-to-one correspondence between the elements in set and elements in n, a countably infinite set is also known as denumerable. A set is either finite or denumerable is known as countable. A set which is not countable is known as uncountable. The set of a non-negative even integer is countable infinite. On the other side, uncountable infinite means a set which is not countable is called uncountable infinite set or non-denumerable set, or simply uncountable. For example, set R of all positive real numbers which are less than 1, that can be represented by decimal form 0 and a1, a2, a3 up to where a1 is an integer such that 0 less than ai and ai is less than equal to 9. This is the example of uncountable infinite sets. Third is a subsets. If every element in a set A is also an element of a set B, element of a set A is an element of set B, then A is called a subset of B. You can represent it like this: A subset or equal to B. A subset, this is the subset symbol, equal to B. Here you can say B is a superset of A because A is a part of B. So B is a superset of A and A is a subset of B. For example, if A has 1, 2, 3, 4 elements in a set A and 7, 1, 2, 3, 4, 6, these elements are present in B set. Here you can see 1, 2, 3, 4 of sets A's elements are present in set B. That means A is a subset of B, or you can represent it a subsets equal to B. And there are some properties of subsets. For subsets, every set is a subset of itself. Every set is a subset of itself. Secondly, null set is that is fine that is represent to empty set is a subset of every set, and this is a 5. If A is a subset of B, if A is a subset of B, that means B is a subset of C. If A is a subset, means A is a subset of B and B is a subset of C, then you can say that A is a subset of C. A will be the subset of C. If A subset B and B subset C, that means all are equal to C. A finite set having n elements has 2 raised to power n subsets. Now next point is proper subset. What do you mean by proper subset? If A is a subset of B and A not equal to B, means A is a subset of B but not equal to B, then you can say A is said to be proper subset of B. If A is a proper subset of B, then B is not subset of A. There is at least one element in B which is not in A. For example, A has 2, 3, 4 elements. B has 2, 3, 4, 5 elements. Here you can see in A 5 is not present. So we can say that A is a subset of B. B is not a subset of A and A is not equal to B. Because in A there are 2, 3, 4 elements. There are 3 elements. But in B there are 4 elements and 2, 3, 4 are same. But 5 is not same and is not present in A. So that's why we can say A is a proper subset of B. Now second, the null phi is a proper subset of every set. Now next point is, next set is improper subset. If A is a subset of B and A is equal to B, if A is a subset or equal to B, then A is said to be an improper subset of B. For example, A has 2, 3, 4, B has 2, 3, 4. Both are the same values, both have a 3 elements and both are same. So we can say that A is an improper subset of B because A is a subset of B, B is a subset of A, you can say. And so that's why we can say that is an improper subset. Every set is an improper subset of itself. Now next point is universal set. What is a universal set? If all the sets under investigation are subset of a fixed set, that is known as U, and then set U is called universal set. For example, in human population studies, the universal set consists of all the people in the world. All the people in the world, that is equal to universal set. And next point is null set or empty set. A set having no elements. If a set has no elements, that is known as a null set or void set. It is denoted by this symbol, phi symbol, and phi is equal to curly braces blank. Now next is a singleton set. It contains only one element. If in any set given only one element, that is known as singleton set. For example, here we given S in curly braces. This is single element, and here S in curly braces we can say that X or X belong to N. Here 7 is less than X is less than 9. That means 8 number will be here. This is a singleton set. Now next point is equal sets. Two sets A and B are said to be equal, or you can say A is equal to B. If both have the same elements, therefore every element which belongs to A is also an element of set B. Every element which belongs to set B is also an element of set A. Means if we take here A is equal to 1, 2, 3, and if we take in B set 1, 2, 3, that means both elements are same. Every elements are present in B and B's element are present in A. So here you can say A is equal to B and X belongs to A, that is equal to X belongs to B. These are the equal sets. If there is some elements in a set A that does not belong to set B or vice versa, then we can say that A is not equal to B. Now next set is equivalent set. Equivalent set means if cardinality of the two sets are equal, means whether elements of both sets are different but number of elements, means cardinality of elements, cardinality of both sets are same. If you take in set 1 two values 1, 2, and in B set we take 3, 4, two elements, and cardinality of B set is 2 and cardinality of set A is also 2. Both are same. That is known as equivalent sets. Both have same cardinality of sets. So that's why these are equivalent sets. Now next is a disjoint. Disjoint sets means when cardinality of sets are same but elements of sets are not same, then it is called the disjoint set. Means here we given 3 elements in A and 3 elements in B. But in A we take numbers and in B set we take alphabets. Both are not same. So that's why we can say that these are disjoint sets. And next point is power sets. What are power sets? The power of any given set A is the set of all subsets of A and is denoted by P of A. If A has n elements, that means PA has 2 raised to power n element. This is the formula for calculating power sets. For example, we have given 1, 2, 3, 4. These are the number of elements of set A, and power of A will be equal to 2 raised to power n. That means 2 raised to power 4, that is equal to 16. And we can say that we can make here 16 pairs like 5, 1, 2, 3, 4, then 1, 2, 1, 2, 1, 3, 1, 4, then 2, 3, 2, 4, then 1, 2, 1, 4, 1, 2, 3, 2, 3, 4, and like this there are 16 pairs will be making in under the power sets. Now thank you. If you like my video, please like and share my channel with your friends. If any problem, any query, you can comment in comment box.